Good afternoon, Dragons. I'm here to work with you on the distributive property. We first addressed this in quarter one when we were working with factors and multiples. When we worked with the distributive property, we actually used with the greatest common factor. It helped us decompose larger numbers. In class, on page 5, we had taken many notes, the BA-BY notes. Also in class, we had started on page 6, the practice page. Well, now we need to continue with the practice page so that we can finish our notes on distributive property. I can write equivalent expressions using a distributive property. So here in the first one, I color-coded, you might recall, the whole area, the array model here, the area model here, was 3 times 10. We decomposed it to be 3 times 3 plus 3 times 7. The whole thing is worth 30. This part is worth 9. This part was worth 21. And combined, they were worth 30 centimeters squared. We worked on this one together. 3 times 9. Where did I get 9? I combined 4 and 5 together. 3 times 9, we know should result in 27. If I were to decompose it, it would be 3 times 4 plus 3 times 5, which is 12 plus 15, which equals 27. Notice how the 3 can be pulled out. What does that mean? It means I can write an expression such that 3 times 9 is the same as 3 times, see how the 3 visits the 4, plus 3 also visits the 5. So 3 times 9 is the same as 3 times the sum of 4 plus 5. These are equivalent expressions. Likewise, over here, going back to the original example, how could we do this one? I see a 3 shared by both of the smaller multiplication sets, 3 and 7. When we put those two together, that's how we gain that 10. See, 3 and 7 was 10. So we can prove that 3 times 10 is an equivalent expression to 3 times the sum of 3 plus 7. Let's try the next one. This entire area model is 4 times 4 plus 4 times 6. 4 and 6 together is 10, so we know the entire side is worth 10. So the original expression is 4 times 10. Then we can decompose the expression to be 4 times 4 and 4 times 6. 4 times 10 is 40. 4 times 4 is 16. 4 times 6 is 24. If we look at 16 and 24, that is also 40 centimeters squared. I'm going to color code this in just a minute for you. What we're saying is 4 times 10 is the same as 4 times the sum of 4 plus 6. That would be 40. That'll also be 40. So in here, we have 4 times 4. That is located here. In here, we have 4 times 5. That is located here. 4 times 6. I might have said 4 times 5. 4 times 4 was 16. That is what this area model is worth. This section of the area model is worth 16. and this section of the area model is worth 24. Those two pieces can be composed to 40. I want you to take a minute, pause the video, and attempt to do this one on your own. After you've completed it, press play. So this area model can be looked at as 4 times the full length 12, or it can be looked at as 2 components, where we split the area model part way, where we do 4 times 5 here and 4 times 7 here. So we're either looking at it as 4 times 12, which represents this, or we're decomposing the side length into 5 plus 7. 4 times 12, the entire area, is 48. The decomposition, 4 times 5, is 20, plus 4 times 7, which is 28, which also calculates to 48. What does that have to do with an equivalent expression? The original area model indicates 4 times 12. The new decomposed side length, 4 stays the same here, but we decompose this to be 5 plus 7. 5 plus 7 is equivalent to 12. So here we've got 4 times 12, which is 48. Or, also equivalent, is 4 times the sum of 5 plus 7. We just did 4 times the sum of 5 plus 7 because we did 4 times 5. We did 4 times 7. These are equivalent expressions. How does this relate back to the notes? In the notes, we were showing that 6 times 120 could be the same as 6 times 100 plus 6 times 20. 6 times 100 plus 6 times 20 is the same as 6 times 100 plus 20. What I'm saying here is 4 times 5 plus 4 times 7 is the same as 4 times the sum of 5 plus 7. This line here will result in the same value as this line here. What am I pulling out? How is this looking like the distributive property? What you have to ask yourself is, what does this expression have in common with this expression? These two expressions share the number 4, or rather, the factor 4. So the greatest common factor shared between these two expressions is 4, which is why it can become the number on the outside. Now this factor is on the outside. The other two factors are summed together on the inside of the parentheses. This is how we rewrite the expression. On to the next one. 5 times the sum of 4 and 6. The sum of 4 and 6 is 10, so the whole thing is 5 times 10. Or we can decompose it. We can decompose the side length 10 to be 4 plus 6. So then we have 5 plus 4, 5 times 4, plus 5 times 6. What do these two expressions have in common? The factor they share is 5. Since they share the factor 5, we can pull that out of this lineup, create a set of parentheses, and the other two factors can be summed together inside the parentheses. So I am saying that this will have the same value as this, because this factor is now here. The remaining factors are now inside. And I can prove that using the area model. 5 times 4 is going to equal 20. 5 times 6 is going to equal 30. Originally, 5 times 10 is 50. 5 times 4 is 20. 5 times 6 is 30. I do know 20 and 30 together is 50. I know that 4 plus 6 is 10, so this is really 5 times 10, and it tells me here that this is 5 times 10. I have equivalent expressions all over the place. I'm going to color code it for you. The whole big concept, the 5 times 10 area model, is in green. That is here and here. But we can decompose the side lengths. So I could do 5 times 4, which is part of the area model. That is represented with this expression here, and the value is 20. The other decomposed part is the 5 times 6. That is represented here in this part of the area model. And its expression is here. So I have a partial product to create the full product. But all these expressions, this expression in green, the blue and red combined, is also equivalent to this one here. Here we go again. This is either 5 times 5 plus 5 times 7, or it's 5 times the combination of 5 and 7, which is 12. 5 times 12 is 60. 5 times 5 is 25. 5 times 7 is 35. 25 and 35 summed together is 60. What does that mean for the distributive property? The 5 is being distributed to the other 5, and this factor 5 is being distributed to 7. So 5 times 12 is the same as 5 times the sum of 5 plus 7. I can even take it one more step to show you that this 5 is going to multiply by this 5. And this 5 is going to again multiply by this 7. Now you can see that is that. This is this. All three of these are equivalent expressions. The whole thing would be 5 times 12, which is represented here in this expression with this product. Or I can decompose one of the side lengths and do 5 times 5 and get the partial product of 25. I'd have to add that to 5 times 7, which results in the partial product of 35. Those two sums together also result in 60. The partial product here is portrayed in this expression with this product. This partial product here is displayed in this expression with this product. But ultimately, you get the same result, which is what makes them equivalent. Last problem. Use your knowledge of the distributive property, draw and label a rectangle that matches the equation. I think 6 would go on the outside here. And this whole side length needs to be worth 8, but they've decomposed 8 to be 3 plus 5. So it's 3 and 5. So this box is worth 6 times 3, and this box is worth 6 times 5. So what I see is 6 times 3 plus 5 is the same as 6 times 3 plus 6 times 5. So to get the area of this model, it's either going to be 6 times 3 plus 5, or it's 6 times 3 plus 6 times 5. Either way, you get the same solution. How does that go back to our notes with the BABY? Let's pretend 6 was the B. And 3 was the A. And 5 was the Y. Come in closer here because I'm going to prove a point. So here, the 6 represents the B, the 3 represents the A, and the 5 represents the Y. So B times the sum of A and Y. If I distribute the 6, 6 visits the 3. Therefore, B visits the A. B times A plus 6 visits the Y. 5. B times Y. And that is where the baby shortcut idea comes from. B, the common factor, is multiplied by the sum of A plus Y, or you can distribute that common factor to the other factors and get BA plus BY. Now you have officially finished AIM page 6. I thank you for joining me.